Welcome to this session. In today's notes, we're going to be getting into the heart of discussing stoichiometry. Stoichiometry is kind of a balance, kind of a combination between chemical equations, balancing chemical equations, and calculations with the mole, both of which we've already worked on so far. So in today's notes, we're going to be talking about mole ratios and stoichiometry. So in order to understand stoichiometry, we have to first review the law of conservation of mass. Because when we look at a balanced chemical equation, any balanced chemical equation, like when silver reacts with sulfur, it produces silver sulfide, which is a solid. I'll go back and balance that equation. So what this balanced equation actually means is, well, we can actually split up what it means into three different parts. We can talk about what it means in terms of particles, what it means in terms of moles, and what it means in terms of mass. And all of these kind of go along the same lines of law of conservation of mass, law of conservation of matter, etc. So if we look at the particle standpoint, from this equation, we can determine that two silver atoms will react with one sulfur atom to produce one silver sulfide molecule. From the mole standpoint, if we have 2 moles of silver atoms, or 2 moles of silver, those will react with 1 mole of sulfur to produce 1 mole of silver sulfide. And then if we have the molar mass of silver, we would multiply that by 2, so 2 times 107.9, plus the molar mass of sulfur, 32.07 grams of sulfur, plus, and that would yield the molar mass of silver sulfide, 247.9 grams. And if you add the mass of those reactants together, you get the mass of the product. So a balanced chemical equation really tells us a lot about what's going on within that equation. This one right here, the relationship in moles, is what we're going to focus on a lot in this video, and the concept of mole ratios, and how we can look at a balanced chemical equation and draw connections between reactants and products. So let's take a look at mole-to-mole ratios. If I have a balanced chemical equation, like 2 iron plus 3 sulfur yields Fe2S3. I can actually write relationships between the different reactants and products using mole ratios. So if we are comparing iron to sulfur, we can see that there are 2 moles of iron for every 3 moles of sulfur, and then we can flip that and rewrite it as for every 3 moles of sulfur, there are 2 moles of iron. So really what we're doing here is we are using a balanced chemical equation to compare reactants to reactants, or reactants to products. So let's compare one of our reactants to our product. If we compare iron to iron 3 sulfide, we can write that relationship as 2 moles of iron for every 1 mole of iron 3 sulfide. And then we can also flip that and write it as 1 mole of iron 3 sulfide for every 2 moles of iron. And again, those conversion factors are useful depending on what you're converting from and what you're converting to, because you always want to put whatever you're trying to cancel out on the bottom. We can also compare sulfur, the reactant sulfur, to the product iron 3 sulfide. For every 3 moles of sulfur, there's 1 mole of iron 3 sulfide. And we can also flip that, and for every 1 mole of iron 3 sulfide, there are 3 moles of sulfur. So all of this is really the nuts and bolts of stoichiometry. So let's write out the definition of stoichiometry. Stoichiometry uses balanced equations. You always have to be working with a balanced equation. Stoichiometry uses balanced equations and mole ratios. That's the relationship between reactants and products in a balanced equation. Stoichiometry uses balanced equations and mole ratios to create relationships and convert within a reaction. So stoichiometry is really the math of chemical reactions. We've already learned about the process of chemical reactions and the chemicals in chemical reactions. Stoichiometry is all about the math of chemical reactions. And in order to do a stoichiometry problem, you must first have a balanced equation, and you're going to employ the use of mole ratios when you're converting from one species to another. So if you're converting from reactants to products, or reactants to reactants, or products to products. So here's an example problem. I've already got it written out for you. How many moles of sulfur are needed to react with 1.42 moles of iron? So 1.42 moles of iron are starting in it, and this is obviously going to use the balanced equation from the first page. And we are going to use our conversion factor that's going to convert from moles of iron to moles of sulfur. So we're going to put 2 moles of iron on the bottom, because that's what we're converting from. We want that to cancel. And then we're going to put 3 moles of sulfur on the top, because that's what we're converting to. So moles of iron are going to cancel, and we get that 2.13 moles of sulfur are needed to react with 1.42 moles of iron. And again, I just used the balanced equation from the first page of notes to get that relationship, to get that answer. So let's do one that's a little more complicated. How many grams of iron sulfide can be produced from 14.2 grams of iron? So this is gram to gram instead of just mole to mole. So we're going to start with our starting unit, 14.2 grams of iron, and we're converting to from iron to iron sulfide. So we're going to need a mole ratio in order to convert between these two species. So if I need to use a mole ratio, then I first need to convert grams of iron to moles of iron. I can't just stay in grams. I have to convert to moles so that I can use a mole ratio. And again, the mole ratios were what we wrote on the previous page, all of those relationships. So I'm going to convert to moles of iron. I'm going to put the molar mass of iron under 1 mole of iron. And then I'm going to use the mole ratio that converts from moles of iron sulfide to moles of iron. So I'm going to put moles of iron on the bottom, 2 moles of iron on the bottom, and 1 mole of iron sulfide up top. And that's going to cancel my moles of iron. And then my last step, since I want to get to grams of iron sulfide, I need to convert from moles of iron sulfide to grams, so I'm going to have to multiply by the molar mass of iron sulfide. And, oh, checking my periodic table, I realized that I wrote down the wrong molar mass for iron. The molar mass of iron is 55.85, not 63.55. I wrote down the molar mass of copper by accident, sorry about that. But then the molar mass of iron sulfide is going to be, hang on, plugging in my calculator, 207.91 grams. So we're going to take 14.2, divide by 55.85. Divide by 2. And multiply by 207.91. And I get 26.4 grams of iron sulfide. Okay, so we're obviously going to be doing a lot of practice problems related to stoichiometry, but I've got a challenge problem that I'd like you to try on your own after watching these video notes. How many moles of sulfur are needed to react with 18.62 grams of iron? So you're going to be converting from moles to grams. Moles of sulfur to grams of iron. So we're going to be writing this out. How many moles of sulfur are needed to react with 18.62 grams of iron? So for this challenge problem, you're going to be converting from moles to grams. Good luck.